The term context engineering has become the biggest buzzword in AI in the past 10 days. And it's a word that, if industry leaders are to be trusted, you must now start to learn, with many people calling it the next big evolution from prompt engineering. In very simple terms, prompt engineering is what you ask an AI model to do for you, whereas context engineering is what a model knows when you ask it something. This shift reflects very hard-won lessons when building AI agent systems. You can have something that has all the bells and whistles, but if it doesn't give the right context, it can never deliver good outcomes for people. In today's episode, we're going to discuss the evolution from prompt engineering to context engineering, and I'll break down what context means when it comes to AI. And finally, I'll actually give a breakdown of some of the real things that you as a person are going to start noticing as a result of improved context engineering. This is In the Loop with Jack Horton. I hope you enjoy the show. So I'm going to assume most of you already know what prompt engineering is, but just for the sake of the episode, I'm going to spend 20 seconds on it. Prompt engineering is a phrase that gained mainstream adoption and traction generally after the launch of ChatGPT in about late 2022. And this is because millions of people were suddenly trying to figure out how to talk to an AI system. It was one of the very early job roles that were advertised for by big companies. Prompt engineering became a skill set that people went and did courses about. Generally, it became a really important skill. And engineering a prompt basically meant using trial and error and intuition, really, to find a set of, instructions, and also the way the instructions are worded to make the model do what you want it to do. A really famous example of this was the very famous prompt that literally just said, "Let's think step by step." And this led to chain of thought, which is a form of AI reasoning, which typically improves the performance of how an AI model performs when you just ask it a simple question, because it's making itself a plan and following it step by step. However, as the use cases for AI have become increasingly advanced, so have the steps and the tasks that an agent must follow to actually, deliver value today. And as a result, there were very clear limitations with prompt engineering, because early prompt engineering is essentially a one-shot attempt. So meaning you write a single prompt, which could maybe include a few examples or instructions, and the model will then give an answer as a result. But many tasks require dialogue with users. It requires the agent to memorize things. It requires the agent to use tools, so integrations into separate systems to capture data from those systems. And so, for example, asking a model to, say, answer this question by searching the web and then write a summary can't be done in a single one-prompt attempt. The model needs to take many different actions, like doing a search and remembering what it found and then doing something with that information. And many builders in the space, including ourselves, do things called prompt chaining, which essentially means chaining prompts together to give the model more context at every single step. So it would take a step and then follow another step and use the information from that previous step. And there was many different innovations that include RAG, so retrieval augmented generation, including what's called ReAct, so reasoning and action, which essentially are ways of getting a model to prompt and capture subsequent information and use that as context to provide a better answer. The point being is that it's not actually just the instruction sent to a language model that matters. It's actually the context the language model has and how it carries context throughout many different steps. And this is where context engineering really starts to take center stage, because context engineering is all about deciding what a language model should know before it speaks and answers a human. Not just what you ask, but what data or tools or memories, instructions, and history should be fed into that system to guide its answer. And the term itself became largely popularized by Shopify's CEO very recently on Twitter, who said, "I prefer the name context engineering to prompt engineering. It better describes the core skill set, which is giving the model the context it needs to plausibly solve the task." And there are other big names out there like Andrej Karpathy, who was one of the co-founders or let's say founding team members of OpenAI, and who's very famous and even coined the term vibe coding, who described it more as an art and science of filling the model's context window just enough to make the next step in its sequence work, but not too much and not too little. It's just the right amount of information. So you can almost consider context engineering like orchestration. You're orchestrating an agent over many subsequent steps and trying to control what information and context it should have after each step and how it should use that context in the subsequent one. Let's go one level deeper. and actually unpack what counts as context when it comes to an AI model. Because every piece of software built over a language model, that's Mindset, that's every provider, is essentially this fantastic piece of software that is dictating the context and the instructions sent to a model and how that information is surfaced to a user. And that is where all the hard work comes from, because it's flipping difficult to get it all to work. And you'll see why in a second. There's many layers to context. So you got the first piece of context, which is the immediate prompt. So this is the direct question or instruction by a user. For example, create me a marketing strategy. And this is where prompt engineering has typically been focused. Number two, you've got systems instructions, which are essentially a system message sent to the large language model to set a behavior. So you are an expert travel planner. The second layer is called system instructions. And essentially, this is where you send a system message to a large language model, such as you are an expert travel planner. So this is the context that influences, say, the tone, the scope, and this alone can be quite detailed. We've got an entire agent builder around these, which dictates how to behave, not to behave, guardrails, policy, personality, how it should structure its responses. But that's all system messages. Again, the software built on top of these things are highly complex and advanced just to make sure the right thing is sent at the right time with the right amount of context. So third piece of context is the conversation history, which is often called the short-term memory. So in a conversation with, say, ChatGPT, you want parts of that chat to be included in every single prompt that goes to the LLM. So when you ask a question, it has the context of all previous conversations you've had in that thread. Again, so you might say, as I was speaking about earlier, and therefore it knows what earlier means. And that's because every time a message by a user is sent, ChatGPT as a piece of software also takes the message history, condenses it down, and sends it to the language model, so it then has that context of the conversation. The fourth type of context that's absolutely critical is long-term memory or persistent memory. This can be a summary of previous interactions. This could be stored facts about a user, such as my preferences or information about my profile, or even previous conversations between different threads. So it's that context that persists across different messages. So it knows that you work in a certain job, you like responses in a certain way, you hate things that sound like this. We're actually, as Mindset, launching an entire long-term memory layer next month, which enables our customers to dictate what an agent should remember. Then you've got retrieving external information. So this might be both RAG or integrations into third-party systems. So sometimes you'll ask questions that will require context of external documents or code snippets or videos. And so the software that you'll be interacting with will then call that information, bring it into the prompt that is sent. So your message plus that information from an external data source sent to the LLM, and then the LLM will use that to answer your question. Another example could be a customer support bot that pulls in users' account data whenever it answers a question about billing. You've then got another layer down, which is tool definitions. So if the models can use tools like, say, making API calls or running calculations, to do that, it needs to understand how to actually call those tools or interact with external tools. And it must use the information it gets back to answer or support what it's doing. And so whenever it uses one of those tools, let's say summarizes all my WhatsApp conversations, you then want it to be able to retain the output of that query into WhatsApp for the next step in the process. So yeah, that's different layers of what context actually means in an AI system. Again, it just sounds like a human that requires context to do good work. But it actually has very big implications on what it means for agentic systems. And it's one of the big reasons we're launching a new orchestration system that enables our customers to really give models the right context at the right time. And I think, in summary, and I'll explain why in just a second, simpler processes or sequential step-by-step processes are better than multi-agent systems right now. We've talked about multi-agent systems before in previous episodes, but this is where you have teams of agents doing many different things. And it's really relevant to this conversation because it's all about the concept of context engineering and really highlights why context is so important. So let me delve a level deeper by explaining the problem of having teams of agents doing many different things at once. There are many different use case ideas that people often think, oh, let's get a team of agents to do this. Let's get a team of agents also working on tasks in parallel to each other and then breaking down those tasks into subtasks and getting other agents to help with those subtasks. So the idea might be to have, say, agent A break a problem into small little parts, delegate it to agent B and C, and then have A, say, combine all of their information into one answer. Because in theory, it would just make the responses faster, because you have people working, or shall I say, agents working in parallel, and those agents could be specialized at breaking down tasks, for example, or summarizing information. So in theory, it makes sense, but often it will fail because of coordination. And when we say coordination, what we actually mean is context. Context not being shared between different agents. Now, there was a fantastic paper recently released by Cognition Labs. Again, one of the labs behind what's called the Devin agent, one of the very famous coding agents before the new age coding apps emerged. And their paper was called Don't Build Multi-Agent Systems. And to show why, they actually tasked a set of agents to build a Flappy Bird clone. To accomplish this, the AI created sub-agents. One to create the background graphics, and another one to create that player bird, the thing that you're going to control. Now, without the full context, the first sub-agent might interpret the task a little bit different and generate a Mario-like background instead of a Flappy Bird pipes background. Now, they're very similar but slightly different. But the second agent might then produce a bird that doesn't therefore fit with the style of graphics. So when these two agents merge the outputs to combine it into a single game, it obviously doesn't work. It feels like separate products. And the root cause of this is that the sub-agents lack the full context of the original objective and the work of other agents going on at the same time. Now, the straightforward solution, you might say, would just be give all these sub-agents all the information they need, like the information on the task, the description, any decisions other agents have made, so they can go and do a good job. In practice, that means when agent A, say, delegates something, it should pass along not just the subtask, but also all of the information, the conversation history, everything that's happened up until that point, and all the decisions that led there. However, even sharing the entire context isn't enough sometimes, because the sub-agents then might work with full knowledge of, say, the main objective, yet still produce something that's incompatible, because they may make assumptions throughout that process that conflict with each other, like one deciding that the game should have a cartoon style and the other a realistic style. Again, you'll notice that every single decision or action by an agent will always have a knock-on effect. And so overall, what Cognition Labs have claimed and believe after much testing is that single agent architectures, which means that one agent follows sequentially a few steps, is far easier to get a fantastic output than multi-agent systems. And it's exactly, as I said, why Mindset is enabling this exact use case, enabling our customers to dictate all the different steps and separate integrations and the long-term memory that an agent should carry throughout a conversation, and essentially what it should do with each part of its data and output at each step. And they're not the only ones that reported this, because Anthropic did a lot of research into multi-agent systems for their research assistants and highlighted the exact same problem. We've personally found that same problem when trying to use multi-agent systems in our own business. So for all the excitement of multi-agent systems with teams of agents doing things and even a single agent doing something really powerful, it all comes down to how well the software product on top of those large language models can prompt and give it context every single time it prompts. So I think this is going to be a growing area of innovation over the next sort of 12 months. And obviously, I believe everything will be solved and multi-agent systems will probably be possible in, I'd say 12 months, but we can always half it and everything happens faster than we thought it would. So I guess the interesting question, therefore, is, as a listener right now, how does this impact you? Like, what should you know about this? Why is this relevant to you? Put really simply, I think good context engineering, either as a user using just something simple as ChatGPT or using a product that's an AI product, good context engineering is where you're left with a sense of that was actually helpful. It also massively influences the types of experiences and features and options as a user that you're going to be given by products. So one of those are going to be personalization. The system is going to increasingly be able to remember everything about you, your preferences and previous conversations. You're going to start to see more user interface and user experience patterns emerge. For example, as AI becomes integrated into, say, apps, designers are going to have to come up with ways to give context to agents without users actually realizing it. For example, many chat interfaces have an upload file button, which enables you to upload a document. From a user's perspective, it's straightforward. I want to talk to a document. But actually what you're doing is giving the agent or the AI language model context. You're also going to have different modes of working. So even if you go on the ChatGPT app, you have the deep research prompt if you're a pro user. You have the Google search. You now have study with me. There's many different options. And what that does is essentially give context to an agent that they built. And it might just be a single agent architecture with a series of steps. It gives it context on how it should behave in that situation. Another big area is managing context in multi-tenant environments. So many of our customers are technology providers, software providers who have, say, thousands of enterprise customers. And each one of them have their own space in these platforms. How, therefore, does an agent or an AI retain conversations and context between all these people and stay secure? So it's an area we've been working really hard at and we're excited to bring stuff out for. But this is the area that's really important because let's take a SaaS platform in sales. It might integrate with every single salesperson's contacts, its CRM, its email. So when a salesperson asks to say, let's say, draft an email, it'll just use all of their data seamlessly, very cleverly, magically, and answer you. But all of that magic actually had to be done quite securely. I think the other one is going to be privacy and trust for you, because I would be worried about what happens with all this data. They're capturing a lot of data on us now. I personally use it as a life coach. I use it for almost any question that I've got. I will almost always go to ChatGPT or another AI system first. So I guess let's just conclude. Early on, we were obsessed with the model itself and how to talk to it with prompt engineering. And over time, we've realized that an AI agent isn't just the model, it's the whole system that feeds it context and interprets its output and uses that output to inform its next set of context. So in a way, we're moving one level above in terms of abstraction. How do I get the model to output X response is more about thinking, what information do I need to give it and guidance to get that best response? Anyway, I hope you enjoyed the episode. I certainly did, and I'll see you next week.